All right, chapter 18, nitration. I hope that's showing up all right. So in a nitration, we're going to put an NO2 group onto the benzene in place of H. So the electrophile is going to be NO2 plus. All right, so the NO2 plus is isoelectronic with carbon dioxide, but it's a really powerful electrophile. And NO2 plus has been used to nitrate all sorts of things throughout history. So if you want to make nitroglycerin, you mix nitric acid and sulfuric acid, and you mix in glycerin. The nitroglycerin separates as a separate phase, and you have to purify it. The purifying it's the hard part. Don't do this at home, right? Like you guys are all at home right now. I'm not advocating that. I think it's a federal crime, and it's certainly dangerous as hell. So don't do it at home. But you can also nitrate. We're gonna see another nitration you can do. I'll actually do it with. No, I don't think I will. I'll do it with benzene first, and then when we talk about substituents, we'll do a nitration that gets an explosive. So let's look at how this works. First of all, the mechanism to do this is, I think it's wrong in the book. There's argument about it, and so if you look at the structure of nitric acid, that's it. So it's a nitro group bonded to an OH. Now, if you're going to protonate this molecule, where would you protonate it? You'd protonate it there, right? And so what happens, this O grabs the H, you wind up with protonated nitric acid, hydrogen sulfate up there. You can find the mechanism that's given in the book. They protonate here. That's not the oxygen that would be protonated. But structures like this decompose spontaneously to in this case, NO2 plus and water. So if this is carbonic acid, you guys might have actually done this reaction. If you haven't, you can go do this. If you're bored, summer, it's easier, it's better doing organic homework. Go to the kitchen, get some vinegar and some baking soda, mix them together, and you will make carbonic acid. This is the structure of carbonic acid. Carbonic acid spontaneously, and this is a bimolecular reaction, so two of these goes to CO2 and water. It's two of those, it's self-catalyzed. It's a long story and I don't have time to get into it. Basically, carbonic acid catalyzes its own decomposition. That's why this goes so well. You get carbon dioxide. So if you do this in your kitchen, put it in the sink, you'll get bubbles. You can clean it up easy. In solution with nitric acid and sulfuric acid, you see how these two are exactly the same structure? So the protonated nitric acid simply decomposes to NO2 plus and water. Okay, so that NO2 plus then is going to be our electrophile, and water is going to be what takes the base. So now we have benzene is going to come in here. Nitrogen can't have 5 bonds. Don't draw 5 bonds to carbon or to nitrogen. So benzene comes in and attacks. Get a neutral nitro group. So remember, the nitro group has a positive nitrogen, one negative oxygen. That negative charge is delocalized. We also have water in here, so now the thing that takes the proton at the end, so right, first step of electrophilic addition, second step of E1, and you've put a nitro group on and you've made some acid. All right, so that's electrophilic nitration.